Hi. So in this second talk about the importance of definitions in math and in real life sometimes, I'm going to talk about the issue of incomplete definitions, and this is probably one of the most interesting examples that I'm aware of. If you, of course, know something similar along these lines, you can drop a note in the comment section. This is actually a well-known mathematical paradox, and it's not a question of whether it's a paradox or not, but there are various competing explanations as to where the error is in the reasoning that I'm going to show. I'm going to focus on one interpretation of the error, which lies, as I said before, in the issue of definitions of mathematical concepts, or in this case, the definition of a specific variable. So the paradox is called the exchange paradox, or the two envelopes problem. And I'm going to put it here under the parenthesis, the incomplete definitions issues, because that's what I'm going to focus on. How an incomplete definition actually is basically one explanation of the paradox. So again, if you want to know more about the topic, you can actually pause the video and then Google two envelopes problem or the exchange paradox. Again, there's a quite large literature on the topic, so I'm going to just state briefly what the problem is, the statement of the problem, and then the question, and then whether the answer is yes or no. And basically, we're going to show a little proof as to why the answer should be yes to the last questions in the statement and why that's wrong. And that the main question is why the argument is wrong, because there shouldn't be any problem understanding that the proof that I'm going to show has to contain some errors. So the experiment is as follows. You are given two identical envelopes, closed envelopes that you won't be able to distinguish between the two, but you know that each contains money, and one contains twice as much the amount on the other. And then you get to choose one randomly, and then you get to keep the money if you are happy with your choice. However, right before you open it, you are given the opportunity to switch. So you are presented with three envelopes. You say, okay, I'm going to pick this one, but then let's say the owner of the game says, are you sure? Would you like to switch before you open it? And the proof I'm going to show is to give an argument that you should switch, which right off the bat shouldn't make any sense, right? Because if the envelopes are identical and you have absolutely no other information besides the fact that one contains twice as much money as the other, there shouldn't be any difference in the expected amount of money you get if you play this game repeatedly. So the wrong proof will be essentially to show that you should switch, which doesn't make sense, again, because by doing so, you actually increase your expected amount that you could get if you, again, play the game repeatedly. So for those of you not familiar with probability theory, just remember that the expected value essentially is, in average, if you play the game repeatedly, how much you get on average, how much payoff you get on average, right? Because each payoff will have a certain probability assigned to it, right? So there's a 50% chance you get the lower amount, 50% chance you get the higher amount. And if you keep on, depending on the amount you get, if you keep on repeating the game, you should be able to predict on average how much money you will get in the end. So if by switching you increase the expected value, that definitely you should switch. Okay, so the argument goes like this. So suppose we have, let's represent the two envelopes by two rectangles. This is the first and the second envelope. And the argument goes like this. So suppose that the first envelope contains X amount of money. So in other words, I'm going to essentially denote by X. So let X denote the money amount basically in the first envelope. Okay, and if that's the case, then we have essentially in the second envelope either twice as much amount of money with probability 1/2, and I might be actually out of this marker. Let's see. And then in the other one, you could have, let's choose a different marker. And in the other one, you could have half the amount of money. So x over 2 with probability 1 over 2. Again, all right? So either you get twice as much or half the amount with equal probability. Okay, so should I switch? Well, on one hand, if I'm happy with the choice, let's say I picked envelope 1, and if I'm happy with the choice, then I get whatever that amount is, X dollars. If I make the switch, I get either this or this with equal probability. So therefore, the expected value, if I switch, will be 2x times the probability 1 over 2 plus x over 2 times the probability 1 over 2. All right, so that makes it x plus x over 4. That gives me 5x over 4, which is, of course, greater than x. So by this argument that, yes, I should switch before I open the envelope, again, this shouldn't make sense if you think about it. And we can show immediately, actually, with one funny mathematical argument why it doesn't make sense, but a much more straightforward argument if we actually take an example as to how much money is in each envelope. So this seems to be along this line that I should switch. Now here's a math reasoning that I can put here immediately on top of this, underneath this argument, that not only doesn't make sense, but it can lead to funny conclusions if you think about it. So let's say I do believe this proof, so to speak, and I say, okay, I'm going to switch before I open the envelope. But then the owner of the game can say, okay, well, are you sure? How about you switch again? I mean, should you change your mind and then switch back to the original choice? And then I could essentially use the same reasoning, but now from right to left. I could say, okay, well, let y dollars be the amount of money in the second envelope. And then, of course, with equal probability, in the first envelope now, I have either half the amount of dollars, y over 2, or I could have twice the amount of dollars, that's 2y, again with probability 1 over 2. And then if I compute the expected value, then I get, of course, y over 2 times 1/2 plus 2y times 1/2, which gives me 5y over 4, which is, of course, greater than y. So keep in mind that if I change my mind once before I open the envelope, it seems that I increased my expected payoff. And if I change my mind again, I increase it further from right to left. So the conclusion would be here is that by keep on changing my mind indefinitely, I can increase my payoff indefinitely. I can go from the original payoff, or what I expect in one envelope, to slightly more, and so on and so forth. So obviously that doesn't make any sense. And the funny part, of course, is that you don't get any dollar because you will be always compelled to switch the envelopes, and because it always seems to be you get a higher payoff. So rather than picking an envelope, you keep on switching. Incidentally, actually, a friend of mine said that you should probably take both envelopes and run. But of course, that's a different story, right? So that's not allowed in the conditions of the game. Okay, so here's another argument why definitely this should be wrong. Okay, so the main question is not whether it's wrong or right, this argument. The question is, what is the mistake, mathematically speaking? So one quick argument to show that this is actually wrong, let's actually use an example as to how much money is in each envelope. So suppose that the two amounts, the lower and the larger amount, is, let's say, $6 and $12. So on the two envelopes, you have essentially two possible outcomes, but they are linked. So that's basically a little bit of suggestion of why the mistake is, and we're going to talk about that later. Once you actually assume something in the first envelope, that influences what you should assume on the second envelope. So if the amounts are $6 and $12, then there are essentially two possibilities if you look at both envelopes at the same time. Either you have $6 in the first envelope and 12 in the second, or you could have $12 in the first envelope and $6 in the second. So, the payoff is really the same. Okay, you pick randomly envelope 1, you get either $6 with probability 1/2, or $12 with probability 1/2. You decide to change your mind, well, either you get $12 with probability 1/2, or you get $6 with probability 1/2. What's the payoff? It's the same in both cases, right? So it's going to be 3 plus 6, which is $9, the expected payoff. 6 plus 3, $9. Okay, so then again, the question is, although there are actually, I met one person who actually still believed that, actually does show that you should switch. I hope by looking at the actual example, it's pretty clear for everybody that there's no reason to switch, right? The expected payoff is the same. So again, the main question is actually what the mathematical error is. I mean, in mathematical paradoxes that are presented sometimes in the literature, the question is either whether it's a paradox, because sometimes it's not. It's more like more subtle mathematical argument behind it, or it is indeed a paradox. But then the interesting question is to pinpoint what the mathematical error is in the so-called proof. And there are various interpretations of what the error is. Again, there are many bigger articles. One possible interpretation, which in the Wikipedia article actually on this is just a small footnote. The one I want to talk about here is essentially the incorrect definition, or if you want, the incorrect use of the variable x. So actually the key thing in any word problems, if you think about, lies in what you call the variable to represent. So this is actually sometimes students don't spend some time, especially in word problems, because they are rushed to get to the equation and actually solve the math involved. But really, the setting of the variables and their definition, or their meaning if you want, it's really crucial, because this is where the error lies, at least in this particular case. So notice, when I say let x denote the money in the first envelope, this is actually in the way I used that variable x, that's an incomplete definition. So, and that basically caused me to use the variable, or to use x, to mean actually completely two different things. Well, it means something clear, the money in the first envelope, but the way I used it to estimate what happens if I switch basically caused me to use x to mean different things. So in other words, if I choose x to denote the first envelope, I must specify whether it represents the lower or the higher amount. It is not correct to say that's it, let x be the money in the first envelope, because if you use x to denote the possible outcomes in the second envelope, you gotta make up your mind whether it represents the larger or the lower amount. So to put it simply in this example, let's say I start with x in the first envelope, right? So x amount of dollars. Then the second envelope, so that's envelope 1, and that's envelope 2 here. Let's put it in the frame. So the second envelope contains the half of the amount, x over 2, only if x is the larger amount. So I hope that makes sense, right? So only if it's the large amount, right? So for example, if you have $12 in the first envelope, the only possibility is that the second envelope contains $12 divided by 2. So $12 divided by 2, which is 6, but not $12 times 2, which will be 24. That is not possible. And so that lies the error here. It is not true that in the same probability space, essentially, the second envelope contains 2x or x over 2. It's going to be either 2x or exclusively or x over 2. Not both. Not with both with equal probability. Again, imagine you have $12 in the first envelope, which essentially is a possible value for x, that the second envelope must contain 12 over 2, but not 12 times 2. And now by the same token, if x denotes the lower amount, right? Then of course the second envelope can only contain 6 times 2, which is $12, but not 6 over 2, which will be $3. That's not a possible outcome. So in other words, in fact, with probability 1, the second envelope should contain 2x or x over 2. But that forces you to make up your mind as to whether x denotes the money, the large amount of money or the small amount of money. Okay, so that being said, let's actually come back here to the original setting. If I were to use a precise definition of x, then again I have to make up my mind and choose either the large or the lower amount to denote in this for x. All right, so essentially, let's see this way. One version is to say, let x denote the small amount. Then the possibilities are, of course, either x in the first envelope, 2x in the second, or 2x in the first envelope and x in the second. Whatever you pick, a first envelope or second envelope, the payoff is the same. You get x dollars times 1/2, probability 1/2, plus 2x times 1/2. The payoff will be 3x over 2. So in my example, if x is $6, then of course payoff is 3 times 6 over 2, which is $9. Now, if you decide x to denote the large amount, so let's say let x denote the large amount, then of course in that case the possibilities are either x in the first envelope and x over 2 in the other one, or x over 2 in the first one and x in the second one. No matter what you pick, the expected payoff is going to be x with probability 1/2, x over 2 with probability 1/2, and that makes it 3x over 4. So of course, in the same example, if x is 12, the larger amount, then the payoff is 3 times 12 over 4, which is 3 times 3, which is of course the same amount as we expected, as it should be, right? $9. So what will be basically a connection with real life examples? There are not many that come to mind. I mean, there are plenty, of course, but one of the easiest that comes to mind, because this is, of course, a huge subject of debate among people, is, for instance, debates among religious people. So let me point it out here. I'm not talking about debates between atheists and religious people, because in that case, it's not a matter of definition. One side, of course, takes God for granted; the other side doesn't. But among religious people of various factions or denominations, to be more precise, this is somehow comparable, because up to a point, the two sides of the debate actually agree on a definition, but at some point they split, or they leave an important aspect of the definition unsettled. Okay, so let's say the two sides agree that God is the entity that controls the universe, but then each of the sides of the debate has his or her understanding of whether that entity, of course, let's say, dictates a certain duty to the followers, what is a sin, what is not, and so on and so forth. So we have essentially the problem of incomplete definitions in that case. And again, if that's the case, the debate can never be resolved unless the people completely understand each other in terms of what the definition is to the word they actually work with in the debate. Another example, for instance, is, again, more common words that used to mean something and then slowly they mean something else for a large group of people. But again, if the two groups meet and have a debate, there is a common portion of the definition, but then it splits. And again, if it's not noticed, you will have essentially hopeless debates because of the reason. Like, for example, let's say the word violence, which can encapsulate lots of things, and which are actually commonly understood by the two sides of the debate. But then the word evolves to include something else, and then the two sides again may not agree on that inclusion of the word or not. So, for example, obviously they will agree that this word means physical injury. Maybe, well, I'm out of range a little bit. So let's actually write it in a column. So the word violence can include lots of attributes, that are commonly understood. Let's say physical injury, let's say abuse, we could also probably include credible threat inside the definition of the word violence, right? So I mean, even though there's no physical injury manifested right away, now of course if someone comes with a weapon and threatens me, everybody will agree, probably, or most people will agree, that that's part of the word violence. But then let's say this basically splits at some point, and then inside the word, for example, it's included things like, let's say, insults. Because an insult, for example, can be perceived as a form of violence. Half jokingly, but not maybe completely joking, we can put something like, I don't know, mean looks. Okay, so it's not far-fetched that basically the word expands at some point to attributes that may no longer be shared with the person inside, with the person that the debate takes place. So the other side of the debate, put here a question mark, because that person may not share the same attributes for the definition of the same word. This is, of course, a bigger topic than I make it to be here. But again, I want to make this comparison of essentially using one word and analogously to the variable, in this case, to the math variable, in which there is actually a commonality in terms of the definition, right? So for example, when I say let x the amount in the first envelope, that's not necessarily incorrect. It's just that in the context of the problem, it is incomplete. And in the same proof, I basically use another very important attribute in one way or the other, right? So I mean, in one half of the argument I use, without stating so, but I use the fact that x was the small amount of money, and in the other half of the same argument I use the fact that x is the larger amount. So imagine there are actually two sides of a debate in which one person thinks about the lower amount attributed to x and the other the larger amount. But without actually specifying this in the discussion, of course, the conclusion could be wrong, or in the case of a debate, the understanding of the parties could be completely way off, right? Because, for example, this person could say, you gave me a mean look, I'm going to call the police, and then the other person is puzzled, because, of course, the understanding of the word violence splits off at some point. Now, that's not to argue whether the word should be redefined or not. The whole point I'm making here is that without a complete agreement of the relevant definition of the word used in a debate, everything is kind of pointless. Almost everything is pointless in that side in that type of argument. And then the problem is, of course, it may not be that obvious what is the missing part that it's still not defined. As in the case of the envelope paradox, it's not necessarily easy to see that the issue is with the vagueness of the definition of one variable, in this case x. So that's it for this presentation. I'll see you next time.